Hi folks, we're here today to cover the validation of the sample tubing setup that you would have in your facility for aseptic processing. If you have remote particle counters connected to a filling line, you will have no doubt longer tubing with bends to access where you need to put your remote particle counter to gain access for your sampling probe to sample in the critical zones. So there is a standard that had been released in November. It's actually a technical report from ISO, and this standard title is ISO TR 14644/21. And this particular technical report was released to address the issues with particle losses in sample tubing for your monitoring systems. So there's been a lot of discussion about the release of this technical report, and a lot of companies have been affected because they've had previous installations where the sample tubing has been long, number of bends in that tubing. And these are the issues that we want to address when we do have long lengths of tubings and a number of bends in the sampling system. There are issues related to particle losses. So there's a decision tree in the SOP, in the actual standard itself, and that decision tree will determine when you need to validate the sampling system, because now there is an expectation for you to validate the particle losses in your sampling system. And today we're going to go through an SOP that we've developed, and this video tutorial will actually give you a good insight how to validate the losses in your particle system. So quick overview, we got two particle counters. We're using two portables because of the ease of use of getting portables into an area that we can test. We're testing in an ambient environment here. It's probably equivalent to a grade D. And we're getting enough particle concentrations to run the test. So we're going to focus on 0.5 microns and 5 microns. And the tube length that we're going to use for the test is about 3 meters. We're also going to do a second test with reduced tubing length, around 1 meter, to give you an idea of the particle losses around the 5 micron sizes. So part one, we're going to actually test the two particle counters together without any sampling tubing to generate a baseline reading. Part two of the test, we're going to take the sampling system and connect it to one of the particle counters, and as you can see, tubing, lots of ends. And we're going to then run the testing again of the two instruments, side by side, with the sample probes very close to each other. And we're going to look at the ratio of the particle losses between the system without the long length of tubing with the direct sample probe connected, and the system here, the particle counter, with the long length of tubing. So without further ado, I'm going to introduce our metrology manager, David Voer, to come in and do the testing for us and show us how to validate your sampling system. We're here with our metrology manager, David Voer. I'd like to introduce David. David's been with Lighthouse for the last 2 years. He works in our service department for the metrology and calibration service of all of our particle counters, making sure we adhere to 17025 and ISO 2151 Part 4. And right now we are zero counting both sensors of the particle counter, so we verify that the sensors are clean before we start. So David was actually very integral to the development of these SOPs, and David's going to actually start running the tests for us today. So I'd like to introduce David and welcome David to our tutorial.
Thanks, Jason. So yeah, I've been here at Lighthouse Worldwide Solutions for a couple of years, working in the metrology department, helping develop SOPs for a variety of processes and ensuring the highest quality in our calibrations and the most repeatable results for our instruments.
Yeah, we are accredited to 17025, which is a major laboratory calibration accreditation for any laboratory that does calibrations. We're accredited all across our service centers worldwide. So today we're actually setting up the testing. We're going to do test method 1, but before we jump into test method 1, we're going to zero count the particle counters to verify that we're getting zero readings in the sensor. So as we can see, we got a couple of counts here. This will clean up over time a little bit. And generally like 10 minutes with the zero filters on, you're good to go. So once we have the sensors cleaned up, we're going to get into method 1, where we're going to validate the differences in counting between the two instruments before we actually get into sampling the system setup.
So the first step in our test is to choose a test environment. Now you can use the clean room where your particle counters and tubing is going to be installed permanently. but that has a downside of introducing contamination while you're running these tests. So what we're going to do here is test with a mock-up of the exact tubing length and bends that we're going to be using in our clean room. So for our first test, we've connected the isokinetic sampling probes directly to the counters, and we've set our counters to sample 10 one-minute samples. And we're going to orient the samplers so that the tubes are as close together as possible, and we're going to start them at the same time. So I could use a volunteer. All right, on 3, 1, 2, 3. And we're going to let these run for 10 minutes, and we're going to take the average of the samples that it collects over the 10-minute period. Now that our counters have completed their 10 one-minute samples, we're going to take that data and enter it into our form and get the average of the counts for each particle size from each instrument. And the ratio between the counts from one instrument to the other is our baseline error factor. And that number we'll use in the second part of the test to establish the percentage of particles lost due to the tubing. Here in Table 1 of the SOP, we provide a place to enter in manually the data from the reference counter and the test counter. We've also provided an Excel workbook to do the calculations for you for the baseline error factor and the tubing particle loss percentage. For Test 1, you'll take the data that you entered into Table 1 of the SOP and put that into the Test 1 section of the workbook. That will calculate your baseline error factors for both the 0.5 and 5 micron particle sizes.
Now that we have established the baseline between the reference particle counter and the test particle counter, we are now going to look at the sample losses, the particle losses in this 10 feet piece of tubing. So what we're going to do is we're going to have a system set up where we have the unit with the sample tubing, with the 10 feet of tubing, with at least 4 bends. We're exceeding the ISO TR 1464421 recommendation, which means you have to validate. So we're over a certain length of tubing, and we have over 3 bends in the sample system. And we will connect everything together, run one of the units without the tubing, one unit with the tubing, and we're going to look at the ratio of counts.
Okay, so we've got our 10 feet of tubing connected with our 4 bends, mimicking our sample setup in our clean room environment. So we have 1, 2, 3, 4 bends, just like we will for this 10 feet of tubing in our sampling system in our clean room. And we've got our 10 feet of tubing connected to our test counter and a reference counter with its ISO probe as close as possible to the ISO probe connected to the sample tubing. And now we're going to set and start both of the counters at the same time. Now that we've completed the second test with the sample tubing installed on the particle counters, we're going to enter that data into this table in the SOP. We can also take the data from the second test and enter that into our workbook under the Test 2 section. That section will calculate the average tubing particle loss percent by size for the 0.5 and 5 micron particles. The calculations at the bottom include the correction from the baseline error factors determined from the first test. In the SOP, we mentioned that you need at least 100 particles per channel per sampler. If you find that your counts are below that number, you can either move to a more dirty environment, like an unfiltered office room, or you can use an aerosol generator to get those counts a little bit higher so that you can achieve statistical significance.
Well, that about wraps it up for our testing and the validation of the particle losses in the sampling setup according to ISO TR 14644 Part 21. I hope we've given you some knowledge today, and speaking of knowledge, if you want to gain some more knowledge, visit our website and get onto our knowledge center, and there's a lot more information there. We do also offer this as a service to come on site and do this testing for you. If you are being validated by an auditor and you need to validate your particle losses, we can come on site and do that for you. And I'd like to thank David for his participation today and getting this good information out to you all, and we hope to see you again soon.